What's going on, everybody? We are going into chapter 11. Once again, similar to chapter 10. Chapter 11, we will not have a test, but the things from chapter 11 will be on the final. So keep that in mind. Chapter 11 is on perimeters, area, surface area, and volume. And today, specifically for 11.1, we're just going to be talking about perimeter and area of parallelograms and triangles. Just like always, the notes are available in Canvas, so please pull those up, print them, or download them so you can create your own set of notes and help prepare yourself for the final. Okay, vocab perimeter is just a continuous line forming the boundary of a closed geometric figure. Okay, so perimeter is just what is the distance around the edge of the shape. The area is the amount of space inside of the closed geometric figure or inside the shape. Okay, perimeter is the distance around, area is the amount of space within it. How to find perimeter of both triangles and parallelograms. Okay, we just simply add up all the sides. However, remember, think back to our chapter on triangles and our chapter on quadrilaterals when we talked about parallelograms. There are many different ways of how we can find missing side lengths. If you don't have all the information given to you, you can still use the things we've learned in previous chapters to be able to find those missing sides. Okay, so examples of triangles, right? Find the perimeter of the following figures. Right, we just do 10 plus 6 plus 8, which comes out to 24. Okay, 12 plus 5 is 17, plus 9 is 26. Right here, 3 plus 6 is 9, but we don't know this missing side. We see that it is a right triangle, though, so we know that we can use Pythagorean's theorem. So we know that 6 squared plus 3 squared has to equal x squared here. 6 squared is 36. 3 squared is 9 equals x squared. 36 plus 9 comes out to 45, right, equals x squared. And the square root of 45 is not going to be a whole number, but that's okay. The square root of 45 is 6.7. All right, so that means this side is 6.7, which means if you add all those together, that's 12 plus 3 is 15.7. Okay, it's okay. Don't be afraid of decimals. You'll have problems like that in your homework, right? If you have to find a missing side, you might have to use Pythagorean theorem. You might have to use square root. You might end up with decimals. It's fine. Not a big deal. Okay, examples, find the perimeter of parallelograms, right? Here in parallelograms, remember opposite sides are equal, right? So even though it's not given to us, we know that this side is 4, we know that this side is 9. We just simply add all 4 of those together. So 9 plus 4 gives us 26. Right, over here, we have a bunch of x's. So we need to find out what x is before we can figure out what the side lengths are. Again, remember, opposite sides are equal to each other, so we can set that up as 5x minus 18 is equal to 2x plus 12. All right, we subtract 2x. 5x minus 2x gives you 3x minus 18 equals 12. Add 12 to both sides. 3x is equal to 30. Divide both sides by 3, and x is equal to 10. Right, so that's what x is. That's not necessarily what the sides are. So we plug 10 in for x. 2 times 10 is 20, plus 12 is 32. So that means this side length is 32, and because they're opposite sides, we know that they're similar. Also, we can plug that in. 5 times 10 is 50, minus 18 obviously gives us 32, so we know that this is 32. Okay, over here we plug 10 in for x. 3 times 10 is 30, minus 6 gives us 24, which means that because it's a parallelogram, we know that that side is 24. So now we just do 32 plus 24 plus 24, and that adds up to give you 112. So that's perimeter. Just have to add up all of the sides. Okay, area of a parallelogram equation. The area of a parallelogram is just base times height. All right, or you can write A equals B times H. Note, the height has to be perpendicular to the base, right? For squares and rectangles, that's not a problem because they're already perpendicular angles, right? So remember, squares or rectangles, they're already right angles. They're already perpendicular. So for squares and rectangles, whatever the base is, you just multiply that times the height. However, if you take a look over here for parallelograms, that's not a square or a rectangle, we see that these are not forming right angles. So the height is going to be, has to be perpendicular, form a right angle with the base. And an extra note, for some weird reason, I'm still trying to find out the answer. A rhombus, even though it is a parallelogram, has a different equation for area than a parallelogram, a rectangle, and a square. Okay, still trying to find out the answer to why, but just keep that in mind. Okay, so some examples. Find the area of the following figures, right? Our base here is 23. Our height over here is 24. This 7 over here is actually irrelevant. You could end up using 7 to find this side length if you were looking for perimeter, but you don't need it for area. You just do 23 times 24, which if you plug that into a calculator, 23 times 24 gives you 552. Oops, I thought I was in writing. So that's 552 over here. Now we need to use this information to able to find our height, right? This is our height. It's not given to us. We know that that is our base. Here we see that's a 45. We know that that's 90 degrees, which means that that's also 45. So that means that this is an isosceles triangle. We don't really have to do a ton of math here. If this side is 9, we know that that side is also 9 because these are congruent sides due to the 45, 45, 90 triangle. So here we do the base times the height, just 17 times 9, which gives us 153. Okay, area of a triangle. Now you do base times height, but you have to divide it by 2. Okay, you have to divide it by 2. So the area of a triangle is, in the textbook, they write it as half times base times height. I think it's much easier to do base times height divided by 2. And again, the note, any side can be the base, but the height must be perpendicular to the base, right? So in this example, this side length is the base, even though it's not flat on the ground, that's the base, and the height would be perpendicular to it. This is how you would typically end up seeing it. The base is always the one on the bottom, and the height, again, has to be perpendicular. But technically, it doesn't matter. Okay, so some examples here. We just do 8 times 4.5 divided by 2. Right, that's your base, that's your height. So 8 times 4.5 divided by 2, which gives us 8 times 4.5. That gives us 36. We divide that by 2, and that gives us 18. Okay, over here, right, this is our base, right? This is just a random side length, and this is our height, right? So this is our height, right? The reason why we can't use this as our base is because if the height 5 wouldn't be accurate. If we used 13 as our base, the height would have to be this line because it has to be perpendicular to it. So that doesn't really actually help us out, right? So we can't use that, we can't use that, but we can use it to help us find the base. We see it's a right triangle, right? So we know that this is your hypotenuse. So that's 13, let me set it up for you. 5 squared is the side, B is the other side, and we know that the hypotenuse is 13. So that's how you'd set it up with Pythagorean's theorem. So 13 squared is 169, 5 squared is 25, plus B squared equals 169. So 169 minus 25 gives us 144, so that means B squared equals 144. And we do the square root, and we find that B is equal to 12. The square root of 144 is 12. So now we can do base times height. That's just 5 times 6, or 5 times 12, which ends up being 60. So our, it's base times height divided by 2. So that's 5 times 12, that gives us 60. But we have to divide it by 2. I almost said the answer was 60, but we know that it has to be 30. Okay, so again, great point of great teaching point right there. It's always nice to write things out so that way you know. Right, I almost stopped at 60 and said that was the correct answer by forgetting to divide by 2. So write things out. Okay, and that's it. So 2 formulas for area. Perimeter is just adding all the sides together. That's it for lesson 11.1. Have a great day. Go Mustangs.